Alright, welcome to a robotics training session with me, your host, Wayne Thompson, lecturer in the Natural Science Department at the Michael University College, and also a STEM robotics specialist. Alright, so in today's presentation, we're going to be going through a few things that we will want to enlighten the teachers about. Coding is, of course, of paramount importance in today's world, and of course, we'll want to introduce it to our students at an early age. So I'm Mr. Wayne Thompson, lecturer in the Department of Natural Science. That's a photo of me. And the objectives of today's lesson is that we will learn about the basics of graphical programming, robotics and mathematics. So we're going to, of course, go from a very elementary, alright, and very foundation kind of ideas using graphical programming, very easy programming, as we'll get onto. And of course, we will be exploring robotics and mathematics. So we'll talk about like the act of measurement, transportation, navigating a maze, and search and rescue. So these are all things that I think kids will be familiar with, and of course they'll be fascinated about as we go through. So in terms of measurement, there are several measurement activities that we can do in robotics after we put in simple codes in the robot and download it to the robot. In terms of showing or talking about transportation, moving objects from one place to another, and also moving a certain distance in a certain time frame. So we'll talk about transportation as well. Navigating a maze, all right. Of course, for example, farming, as in going through the rows to pick apples or mangoes or whatever it may be in your part of the world, and search and rescue. Graphical programming. The simple behaviors we will be using are forward, backward, turn left, turn right, and move motor. So this is what the actual programming interface will look like. So on the simple behaviors, as I'm going to show you in the programming interface, you're going to have some simple function. If you want the robot to move backwards, you just drag and drop backwards into the programming interface. If you want the robot to move forward, you just drag and drop the forward command in the robotics interface, as I'm going to be showing you. If you want to move an individual motor, so the motor will have, so the robot will have like 4 motors, and if you can select the one that you would want to move also. So to do that, you just drag and drop move motor, as I'm going to demonstrate. Next, turn left, turn right. So of course we can allow the robot to turn left, and we can allow the robot to turn right as well. Alright, so this is the graphical programming interface. On this side, you have a lot of graphical functions, many graphical functions, but we're going to be using only the simple behaviors. With the simple behaviors, there are millions and millions of different applications we can just do by combining the simple behaviors. And by combining a lot of simple behaviors, we can get complex very quickly. Alright, so this is the programming interface. I'm going to show you the real programming interface as well. So this is the graphical robotics interface for the VexIQ robot, and this is the window pane. So you see a new file. If you click on new file, you have a new area in which you can start program. Open file allows you to open an existing file that you would have already created. You can save as well, and then you have motor, sensor, and setup. Alright, so the motor sensor and setup is just an area where you can select the different motors that are going to be used in your robotics activities. So that is standardized, and we'll just allow the default to run. We have firmware. Firmware is a troubleshooting software that when downloaded to the robot, what it does is that it allows the robot's functionality to improve. So if you have an error, re-downloading the firmware just allows you to alleviate such error. And of course, if you want to download the robot, alright, needs no introduction. Once we want to download the code to the robot, we'll just hit this button, download the robot. So it's a very simple interface to use. Alright, as I'll demonstrate. Alright, as I'll be demonstrating. Alright, how The programming interface is here, and of course we will drag and drop any one of these functions in that programming interface. So here, for the first example, we have a command, forward 1, rotations 50. What that means is that the robot is going to move forward 1 wheel rotation at 50% motor power, and that's it. Once we downloaded this to the robot, alright, so we attach the robot to the computer via USB cord, where USB stands for Universal Serial Bus. So once we download, alright, from the robot to from the laptop to the robot will carry out this instruction. Alright, only one instruction is here, so the robot will just move forward 1 wheel rotation, then stops. And this 50 is the motor power, and it's 50% of the motor power. Alright, this function will allow the robot to move 1 wheel rotation backwards at 50% motor power. Alright, in terms of move motor, these are the type of motors you can individually move. You have the left motor, the right motor, you might have an arm motor or a claw motor. You can choose to move these motors individually. Alright, so that's the idea, and you can select the amount of rotations you want them to rotate at and also the motor speed. Turn left just allows the robot to turn left. So if we want to turn left, alright, all we have to do is drag and drop that turn left function, and then we're good to go with the turn left concept. So turning left 1 wheel rotation, turning left 1 wheel rotation just actually allows you to move turn left by that amount. If you want to make a 90-degree turn, we can work out for how long we have to turn for in order to come up with a 90-degree turn. And based on experiments and prior experiments that we'll have done, you'll see that about 0.74 to about 0.75, even in some cases 0.77, depending on the surface now, alright, we can turn left by 90 degrees. Turn right, of course, if you want the robot to turn right, you just drag over the turn right function. Alright, so this turn right function, and it allows you to turn right by 90 by 1 wheel rotation here. If you want to turn right by 90 degrees, again, it's about 0.74 rotations, or alright, about 0.77 or 78, depending on the roughness of the surface. Alright, so in activity 1, one of the activities that we will want you to do is you will type in, you will drag over forward, and you will type in, say, 1 wheel rotation. So type in the rotation of the robot, then using a ruler, we want to measure how far it goes. And then after that activity, so you will type in 1 wheel rotation download, see how far the robot goes. Type in 2 wheel rotations download, alright, measure how far the robot goes. Type in 3 rotations, alright, download the code to the robot. Measure the distance and see how far the robot goes. And then now we will want you to type in some odd rotations, and then now you can try and predict how far the robot will go. Alright, so it's a little bit of a pattern activity, a mathematical activity, alright, that we'll want you to try out as well. So what do you notice when you increase the number of rotations? What do you notice about the distance traveled? Alright, so those are some of the activities that we will want you to do in the robotics. So of course you will have a table, so you can make your measurements by using your ruler. So 1 wheel rotation gets you a certain distance, you put that measurement here. As a teacher, you can also try and calculate, alright, the distance by using the circumference, so that's optional. Alright, you put in 2 wheel rotations and measure how far it goes with your ruler. So the students will be engaged in the act of measurement, and also where the reasoning and the critical thinking comes out now is in the predicting. So if 1 wheel rotation gets you a certain distance, you can put in 2 wheel rotations, and then they can measure, and then they can then try and answer to see what distance they're getting. Alright, so this is helping the students to use the instruments and also be engaged in the constructivist type of classroom. Navigating a maze, we can allow students to Alright, so the educator can allow the students to allow the robot to move forward, then make a turn, then move forward again, then make a turn. And so students can be given several mazes, and they will ask to draw arrows to show what code should be in the robot in order to make these movements. So you have to move forward, and then after that you have to make a turn, and then in order to get to the end point you have to make another left turn, and then you make a right turn. Alright, so that's the concept. So that's the concept of the maze, and these are some of the activities that we want students to be engaged in. Alright, so in terms of moving or navigating a maze, there are several problems that the students will just analyze, and they will figure out what type of movement, how they would have to move in order to move from one place to the next. So we'll write a code to make the robot carry food from the starting point to the end point. At this point, the teacher can also talk about some of the applications. Why would the robot want to move from one place to the next? It can be carrying persons from one place to the next. It can be carrying food from one place to the next. It can be doing a lot of different things when it moves from one place to the next. Alright, what can your robot do on a farm? We can, of course, identify some of the things that are on a farm and then talk about what a robot can do on the farm. So navigating a maze, convert the movement to a graphical code. So just based on looking at the arrows, we can then come up, or the teacher or the student with the teacher's help can come up, with the code for this program. Alright, students will be asked about this one. Of course, this is writing the code from the end and going back to the forward position, and so students will be engaged in this type of activity. So it is programming by allowing students to think through how they'll move from one place to the next in terms of a path, alright, in robotics. Alright, so of course robotics can be used in search and rescue, navigating a maze, and of course transporting things from one place to another. The next thing that we'll talk about is, of course, there can be many games that we can use in robotics. So what we'll be doing is also to look at some of the type of games that students can be doing in robotics. So for this one, this is using an underwater robot, and of course the underwater robot will be playing basketball. So it will be dropping these items through the hoop. For our land robot though, students will say, right, who can come up with a program first, then download the code to the robot first, and then if their robot travels the distance, then they will be winning. And of course, students can also perform the act of measurement, alright, as well. Of course, students will be given path, and they will be asked, what should the robot do in order to move, alright, from the starting point to the end point as shown here. And so they will come up with the arrowed paths, alright, just like in some of the robotics game. Alright, so this is the session and some of the ideas that I would want you to be doing with the robotics. I'll be using the VexIQ robot. Of course, VexIQ robot sponsored by the Micro College. So I'll be using the VexIQ robots, and then we can practically carry out some of these scenarios. So until then, for part 2, I will go on to talking about the graphical programming interface and just showing you some of the things that I'd want you to do. So I'm going to be in the software and just develop some codes, alright, and talk through the codes, and you'll see how simple it is actually. Alright, so my name is Wayne Thompson again, lecturer in the physics department, and of course STEM and robotics engineer as well. So until part 2, see you next time. Bye bye. So welcome to part 2. So this is the graphical programming platform, and the only part of this platform that I'm going to be interacting with is this part here that's called simple behaviors. So in the simple behaviors section, we'll have backward, forward, move motor, turn left, turn right. So what I was saying here in the video is that if I want the robot to move forward, I'll just drag over forward. Notice that the one now has a blue, alright, cursor on it, or it does not have a blue color. Then I can drop it. This allows the robot to move forward one wheel rotation. If I want to download this code, all I have to do is to go File, alright, same thing, Save As, alright, so I'll save it, give it a name, and I'll click Save, and then, alright, the program will be saved, so I can refer to the program in the future. After that now, what I want to do is to download this code to the robot. So when I click download to the robot now, so I don't have a physical robot, but it's very easy. I put the USB on the robot and the USB on the laptop, and all I have to do is click this button, download the robot. It will tell you that the download is completed on the robot. You'll hear a sound, like a trivia sound, or one of those exclamation sound, to say that everything is okay. And then you then put the robot down, press start on the robot, and then the robot moves forward for one rotation. If you want the robot to move forward for 2 rotations, you just click here and put 2. This command makes the robot move forward for 2 rotations. If you want the robot moves for 50 rotations, you just put 50 there. That allows the robot to move forward for 50 rotations. You can also allow the robot to move by degree amounts or rotation amounts, or move for a certain amount of time, milliseconds, seconds, or minutes. Alright, and of course this last part here, the 50 is the speed. And the maximum speed is 100% of motor power. So this formula right now, this code, means that the robot can move forward for 50 rotation, alright, at 100% motor power. Alright, so that's the concept. Alright, if I want to remove that, all I have to do is click on it and press delete on my laptop, and that is deleted. Now, if I want the robot to move backwards, what I will do is to drag and drop backward into this programming interface. Alright, when I do this, I will then now click on File and go Save As again, and just choose a location to save it. Give it a name, and the name that you give it should just be a name that kind of describes what the program does. So you could say moving backwards or reverse or something like that. You save it for future reference, and after that now you will just hit download to robot, and of course the robot will then execute this instruction. So again, in order to download the robot, there is just a USB wire, the same USB cord that you use attached to your phone. It's the same USB cord that will attach one side attached to the phone, one side will attach to the robot, sorry, and then the other side attached to the laptop. Then the software comes from the laptop and is then programmed onto the robot in something called a microcontroller. And then now you can carry out the instructions. So pretty easy. Alright. Say for example, suppose I want my robot to move forward for 1 wheel rotation, then I want my robot to move backwards for 2 wheel rotations. This is what the program will look like. So it moves forward for 1 wheel rotation, then it moves backwards for 1 wheel rotation. Suppose after doing that, I want my robot to turn left. I'll just drag and drop turn left, and it will now turn left 1 degrees. One rotation. If I wanted to turn through 90 degrees, what I have to do is to enter 0.74 thereabout to allow me to turn 90 degrees. And so this is a sequence of instructions. So first the robot moves forward, alright, at 50% motor power, for one rotation, move backward 2 rotations at 50% motor power, then it turn left. Alright, so this is only a turn left. After it turn left, it will stop. And so if you want it to move again, you can just drag over forward. So you come over here and drag and drop, and then forward, and you may want it to move forward for a longer time, so you can say 10 wheel rotations forward. Alright, so that's the concept. And when that command is executed, the robot will stop. If you want to save all of this, again, you can just go File, Save As, Standard. Alright, so click on Save As, give it a name, alright, and a nice location so you know where it is, and then you just go to Download to Robot. Alright, so not so bad at all. Alright, so that's the ideal. So if you want to navigate a maze, alright, so let's just delete all of this. Suppose you want to navigate a maze, you want to move forward for 5 real rotations, alright, then you want to turn left, and then when you turn left you move forward again, and then you want to turn right, then you move forward again. So this is actually an example of a maze. The robot may have to move forward for 5 rotations to get to a certain distance. Then you may want to turn. Say you want to turn right, by 90 degrees. So you want to make a 90 degree right turn, put 0.74. This allows you to make a 90 degree right turn. So turn right, but after you turn right, you're going to just stop. So you want to move forward again. Suppose when you make that right turn, you want to move forward now another 10 rotations, a much farther distance. Then you put in 10. After you have done that, suppose you want to make a left turn, then you would have to drag and drop the turn left function. Alright, if you want to turn left by say 90 degrees, type in 0.74. When you turn left, of course, when you make a turn left, you're not going to be moving. So if you want to move, you may have to drag over forward again. And this time you can move for say 15 wheel rotations. Alright, so that's the concept. And so this is now like navigating a maze. Alright, so we can think through it. So one of the next activities that we'll be asking teachers to do is just to use arrows and then allow the students to just write a program based on the arrows. And then now the students can then, after they have mastered that aspect, just move from a code like this. So forward, then turn right, then forward, then turn left, then forward. So they can move from a code like this, and then they can just go straight into just drawing out a real life motion scenario for the object. So one of the things that we'll be talking about here is critical thinking. Critical thinking and also reasoning, proportional reasoning, and other mathematical skills. The teacher will also ask the students to make measurements. So when the robot moves forward for 5 rotations, how much centimeter is 5 rotations? So they'll use the rulers and they'll measure. So the teacher will assist them in measuring. Alright? When it moves forward 10 rotations, alright, what is that distance? When it moves forward 15 rotations, what is that distance? So we're bringing in mathematics as well, and also skill in terms of investigative skills, measuring skills, and reasoning. Alright, so this is what the constructivist classroom should look like. And so these are the things that you'll be engaged in. So alright, in order to download this to the robot, you just hit download to robot. So you see download to robot. Alright, can't miss it. Alright, before you download to robot, you should always save the file. And click File, Save As. Does that for you, and you choose your location. Alright, everything else would already be preset. And so the only place you'll be working with is here. Using simple behaviors, there are just billions of combination of things that you can do and different ideas. Alright, you can do with students to make a particular lesson engaging. So you could be talking about transportation, and so you could just allow the robot to just make a forward move by 10 rotations. You could just put an object on it, and the students could ask, what is the robot doing? Some students will say the robot is moving forward. Some students will say it is moving forward, but it's also carrying out a duty, it's carrying out a function, it's carrying something with it. Alright, so it is carrying an object, or it's carrying fruits, or etc, etc, etc. Alright, so it's just a matter of being very creative, and of course think about some of the basic activities, and then just use robotics in the classroom to help enhance the whole teaching and learning experience. Alright, so that is the concept. So forward, backward, turn left, turn right is the major ones that you will use, alright, with the students at this level. Alright? And so they will find robotics engaging. Alright? Moving to high levels now, of course, we can do much more sophisticated things. For example, measure the distances at specific time intervals and get a function for the motion, as we have been doing in some of our lab sessions at the Micro-University College, and also lab sessions when I've done my robotics seminars and workshops at other places. Alright, so that's the concept. So one of the things is that we can analyze motion. So it is something that the students can start with at primary school, and right throughout their school life they can be doing robotics at different levels until we hit, say, sixth form, where we can be designing simple robots and also understanding the electronics behind robots. Alright, so that's the concept. But this is the starting point. This is called computational thinking, where you will think in a step-by-step fashion in order to achieve a much bigger task. Alright, so that's the ideal. So it helps with computation thinking. Of course, robotics will also help in critical thinking and problem solving. Alright, also in terms of a teamwork scenario, robotics should also be used as a means by which students will work together, alright, in order to get things done as we normally have to do in our daily professional life. Alright, so thank you for having me explaining robotics and robotics function to you. Alright, it has been my pleasure. There are many applications. We're thinking about just robotic games. Alright, so every time a student gets a question right, alright, their robot can move forward one wheel rotation. Alright, another student gets it right, their robot move forward another wheel rotation. So if a student gets something wrong and the other student gets something right, their robot will be further. And of course, once their robot passes the finishing line, they will be the winner. So there's also robotics in assessment as well, alright, especially at this level. Alright, so thanks for having me. My name is Wayne Thompson, lecturer at the Micro-University College, STEM and robotics engineer and robotics consultant. So this is the end of my presentation. Thanks for having me. Bye-bye.